Okay, now we're going to review the things you're supposed to know about derivative graphs. So we're going to assume this graph here is of the derivative, and I want us to talk about what that tells you about the original. So the first thing is I look at what's positive and what's negative, and by positive I mean what is above the x-axis, so here and here. And by what's negative, I mean what's below the x-axis. So this section over here, and this here, and this here. Okay, so being above the x-axis tells us that the original graph is increasing. So this whole section between -3 and -1 tells us we're increasing on F. And over here, we're increasing on F. Now again, this is the graph of the derivative, so we're talking about the original graph, which is not what we're looking at, but this tells us things about it. Where we are below is where the original is decreasing. So I'm decreasing before -3, between -1 and 2, and between 2 and 4. Now, some of you might say, well, why did you not include 2? Well, because at 2, it is on the line. It is at 0 on the line. And it's not below. If it's on the line, it's not below. And so that is something different. You could only say it would be decreasing from -1 to 2 and from 2 to 4, but you could not include 2 in that section. All right. Okay, the next thing I want to talk to you about is what else this graph will tell us. Again, we are assuming that this is the derivative graph. So besides the increasing and the decreasing, what does that tell us? Well, if it changes from negative to positive, it's changing from decreasing to increasing. And if you think about a graph that changes from decreasing to increasing, what happens? It has a minimum. So that means I have a minimum at -3. I would also change from negative to positive at 4. So -3 and +4 would be minimums. And then you would have a change also when you change from positive to negative. Changing from positive to negatives mean you're changing from increasing to decreasing. And so what happens is you get a maximum. So we're going to have a max at -1. And you don't have any other place that this graph changes from positive to negative. There then becomes the question of what is going on at 2. And so it hits 0. What does that mean? Well, if we were below the graph here, we were decreasing on the original, and then we're decreasing again. So it's going to decrease and then decrease. But here, that means that you hit a derivative of 0. In other words, you're going to have a horizontal tangent line on the original. So it's going to have to be a flat place. So let's go into a little more detail, talking about where this is increasing and decreasing and what that tells us. So this graph is increasing from -infinity to a little bit before -2, so probably about -2.3 or something like that. So this whole line right here, this, you're also going to increase on this graph here and here. And so what those places tell us is that the original graph is going to be concave up. So concave up. Anywhere that you see this yellow is increasing. The other parts where this graph is decreasing tell us where the original graph is concave down. So concave down on the purple. Alright, so let's go back and investigate what's happening right here at 2. They were below, so you were decreasing. But this part told us we're concave up, and then we're concave down. So if I'm decreasing and concave up, and then I have to have a place with a horizontal tangent line, it's got to be flattened out almost. And then I've got to decrease and be concave down. This is what that's going to look like. I drew an arrow. I should have finished this out. But for this section of the graph, it should be decreasing and concave up, flat, and then decreasing and concave down. So that's what's going on right there. Okay, so now I am going to basically summarize this whole graph. The first part is below, and it's increasing. So from negative infinity to negative 3, we are going to be decreasing, and since it's increasing, we're going to be concave up. Okay, so that's this section right here. Below the graph means we're decreasing. The fact that it's going uphill, the derivative graph's going uphill, means the original is concave up. Then from negative 3 to what I'm going to say is negative 2.3, it is above the line. So from negative 3 to negative 2.3, above the line means that we're increasing. And again, the fact that this graph, the derivative graph, is increasing means we are concave up. From negative 2.3 to 1, we're still positive. So negative 2.3 to negative 1, it's positive, therefore you mean the original is increasing. The fact that this section of the graph is downhill for the derivative means that the original is concave down. From negative 1 to 0, we're below the graph again. So negative 1 to 0, we are decreasing on the original. It is going downhill, so the original is concave down. From 0 to 2 would be my next section. It's again below the graph, so we're decreasing. And it's an uphill section, which means the original would be concave up. From 2 to about 3.4, I'm going to say. We are below the x-axis, so that means the original is decreasing. And this is going downhill, so the original is concave down. Then from 3.4 to 4, we're below again, which means the original is decreasing. And it's uphill, so the original is concave up. After that, the last section from 4 on is above the x-axis, so from 4 to infinity, we are going to be increasing. And because this graph is increasing or going uphill, the original is concave up. Okay, so now I'm going to go through and talk about, again, just looking at this, calling out maxes and mins and things like that. So again, because negative 3 changes from negative to positive, we have a min. Negative 1 changes from positive to negative, so you have a max. 2 is a flat place because it hits 0, but it doesn't change sign. 4 changes from negative to positive, so that is a min. Points of inflection, you can also point out, those will be your critical points or your maxes and mins on this graph. So on the derivative graph, if I'm looking at a max or a min, that is a point of inflection on the original graph. So I have a point of inflection here, a point of inflection here, one here, and here. Okay, sometimes you get questions like this where you are trying to choose which graph is the original and which graph is the derivative. And sometimes they'll give you three graphs where they're either the original, the derivative, and the second derivative, or you have an original, a derivative, and another graph that's unrelated. So I'm going to tell you how I think about it. The first thing that I do is I just pick one. I pick one to start with. So if I start with the red one, the first thing I look at is, okay, the first section of the graph is decreasing. So this part is decreasing. Is the first section of the other graph below the x-axis to the same point that this decreased? And this one is below the x-axis, but only to here. It doesn't get as far over as you did on this graph, the red graph. So once I've decided that that didn't work out the way I wanted it to, I move on to the blue graph and I say, okay, the blue graph is, the first part of it is increasing. And when I look at the first part of the red graph, is it above the x-axis to that same point? And it is above the x-axis to the same point that the blue graph was increasing. And so right now it's looking like the red graph is the derivative and the blue graph is the original. So I'm going to check another part. And so on the blue graph, the next part is decreasing to about right here. So I'm going to look and see, is the red graph below the x-axis to that point? Yes. Okay, so the red graph was below where the blue graph was decreasing, and I could go through the entire graph like that, but that seems to be the way it's lining up, and it definitely didn't line up the other way. And so since that's the case, I'm going to say that the blue graph is f of x, and the red graph is the derivative of x. Okay, on this next graph, this is a similar situation to what I had before, except now I have three graphs, and these happen to be all related. This one is a little bit easier to look at and maybe pick out than the last one, because you can look at the general shapes of the graphs, and if you remember the toolbox functions that I had you memorize, you can think about the powers, because these are coming from polynomials. You can think about the powers and the shapes that those create and how those relate. So the easiest one on the page is the green one, which is some version of an x squared graph. It's not perfectly x squared, so it's something with an x squared type of power. Then the blue graph has an almost x cubed type look if you focus on it. And the red graph has a W type shape, which comes with even higher powers, and so in this case probably x to the fourth. And so if you just look at the general shapes created by the powers, you can determine that the red graph in this case would definitely be the original, f of x. The blue graph would be f prime of x, and the green graph would be your f double prime, your second derivative of x. But again, it has those same relationships that I just talked about, where say the red is decreasing, the blue is negative. Where the red is increasing, the blue is positive. And the same relationship between the blue and the green, where the green is, or excuse me, where the blue is increasing, the green is positive. Where the blue is decreasing, the green is negative. And so those same relationships are here, but this is a fast one to do. Just if you know those shapes, it can be a little easier.